I thought I'd talk about NGC 1. Well, let's show you a picture of it first. Here it is. This is NGC 1. It's a nice looking spiral galaxy, one like many other spiral galaxies, but quite a pretty spiral galaxy, nice bit of star formation going on, which you can see in the kind of the blue young stars in its outskirts here. So nice spiral galaxy. It's reasonably distant. It's not a huge distance away. All the NGC galaxies are not ridiculous distances away because actually they're relatively nearby bright galaxies for the most part. Okay, so I guess we need to start with the NGC bit. NGC stands for the New General Catalogue. As with many things that are called new, it isn't new anymore. It was new when it was made. So it was actually made sort of the end of the 19th century. And it was called the New General Catalogue because it replaced the General Catalogue, which was the catalogue that preceded it. And so here is the paper. It's the New General Catalogue of Nebulae and Clusters of Stars, being the catalogue of the late Sir John F.W. Herschel, Bart, revised, corrected and enlarged. And it was made by this chap, John Dreyer, who was a Danish astronomer, but actually spent most of his career working in Ireland, both in the south and the north of Ireland at different times. So John Herschel was William Herschel's son. So William and Caroline Herschel kind of did the first go at collecting a catalogue of galaxies and star clusters, or nebulae as they were then called, because they didn't know they were galaxies. And then his son John kind of took over, made a whole load more observations, actually did a lot of observations from the southern hemisphere, because obviously there's a whole load of other galaxies that you can't see from the northern hemisphere to kind of increase the size of the catalogue. John then put together this catalogue of star clusters and nebulae called the General Catalogue, which this was kind of intended to supersede. It turned out there were lots of problems with the General Catalogue. In fact, there's some wording. Let me see if I can find the wording here. He's a little bit rude about it somewhere in here, if I can find the wording. Although the probable errors of results are much smaller, blah, 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 the observations of the two Herschels, so that's the father and son, which naturally arose from the construction of their instruments and the haste with which the observations often necessarily were made, there are, therefore, many cases where the General Catalogue, although evincing the most scrupulous care, both in observing and reducing, is not in accordance with the heavens.
Which is pretty important.
Which is, kind of the nature of these things, that you really want your catalogue to say where the galaxies are and, what type they are. And so it's quite a subtle dig in that he's saying, they took a great deal of care over it, but they still messed it up from time to time.
So the New General Catalogue isn't so much a tweak of the General Catalogue, it's more of a reboot, is it?
It's pretty much, so it took the General Catalogue, it added a whole bunch of observations that other people have made. Sometimes those other observations were correcting things from the General Catalogue. Other times they were completely new observations and produced this completely new catalogue. Having said that, the New General Catalogue also has a whole bunch of errors in it. There are some places where it says there's a nice big bright galaxy here, and if you point the telescope there, there's nothing there at all. So some errors necessarily propagated through. But it's kind of an improvement on it. It's much larger. It's about 8,000, almost 8,000 objects in total. Galaxies are still known by their NGC numbers today. So typically, if it's a nearby bright galaxy, it'll have an NGC number, and that's sort of the usual name that's used to describe the galaxy.
Just for Deep Sky Videos viewers, where does the Messier catalogue, that they will be very familiar with by now, fall into this? That's older, isn't it?
Much older, so that's sort of 18th century, so this is the end of the 19th century, so more than 100 years later. Some Messier objects are in the NGC. I think most of them probably are, actually, because they're all kind of big bright nebulae. So they will have an NGC number as well. But, the Messier catalogue is 100 or so objects. This is, almost 8,000 objects. And then having done that, he found he'd missed a whole bunch of galaxies. And actually, while he was compiling it, more and more galaxies were being found. This was happening at sort of the birth of photographic astronomy. So people were finding much fainter galaxies than they'd been able to find before. And so there was a whole sort of supplement to the NGC that Dreyer came up with called the Index Catalogue. So quite often you'll find galaxies called IC something or other, and they're from this sort of supplement to the NGC that Dreyer came up with subsequently, kind of at the very beginning of the 20th century.
I feel like Dreyer should be a really big name then. I've heard of Herschel, I've heard of Messier. I'd never heard of Dreyer before.
He is surprisingly not that well known, because, I guess because his main claim to fame is that he just compiled these catalogues. And that's not really the thing that kind of gets you the big profile in astronomy, right? He wasn't making the great discoveries for himself. He wasn't out there making the observations for himself. Mostly he was just compiling this catalogue. So once you've decided you're going to make a catalogue, you have to decide what order you're going to put the galaxies in, okay? And the way they're arranged in the NGC is they're arranged by right ascension. So right ascension is kind of the astronomical equivalent of longitude. It's measuring where in the sky things are. And so basically you start at some particular sort of longitude on the sky, and then you go east from there. And east, in astronomical terms, east is to the left, not to the right. Because if you think about it, if you're lying on your front and your head's pointing north, then east is on your right. Right? That's kind of where people think east ought to be. But if you're lying on your back, looking up at the sky with your head pointing north, then east is actually on your left. And so east kind of increases to the left on the sky. So basically you start at this particular line on the sky and then you work your way around the sky towards the east, so towards the left.
And where is this line drawn? Where is this prime meridian of space?
It's kind of arbitrary, but it's to do with where the sun is at the equinox. Suffice to say, it's kind of, you could have picked any point, just as, prime meridian ends up going through Greenwich, you could have picked anywhere on the Earth. We could have picked anywhere on the sky. We pick a point on the sky that's related to the equinoxes and the solstices. And so basically it means that the NGC1, so 0 on this scale, is overhead in the middle of the day in springtime or in the middle of the night in autumn time. Okay, so if you want to observe NGC1, then September's the time to observe it, because that's when it's visible in the night time.
And does NGC1 sit right on the line?
Pretty close to the line. So the other issue is that actually we have to keep changing these coordinates a bit, because the axis of the Earth wobbles around a bit. That means that our kind of definitions of this 0 point kind of changes over time. So you have to keep processing the coordinates or changing the coordinates a little bit, which means that something which is exactly on 0 at one epoch, a bit later on won't be exactly on 0 anymore. So it's not actually exactly on 0 anymore. Right. But so here it is. This is NGC1. And in fact, this guy here, which is just a little bit further to the east, is NGC2. Turns out to be very close to it on the sky. It needn't have been. It could have been halfway across the sky and a bit further away, but it just turns out then they're completely unrelated. They're completely different distances, but it just happens that in terms of how, this is a tiny bit further to the east than this guy. So this is NGC1 and this guy is NGC2. I was going to talk a little bit about NGC1, and actually it sort of fits with the question of why people bother to collect these huge catalogues in the first place. What's the point? Why has somebody gone? Because, so who was it? Rutherford famously said, all science is either physics or stamp collecting. Right? And this is clearly stamp collecting, right? It really is. And so the question is, why do people dedicate their lives to stamp collecting? And the answer is it's absolutely critical for doing science with. And there are a whole bunch of science that you can only do once you've actually collected one of these catalogues and understood the galaxies in it. And you've got this, wide array of galaxies that you can now choose from. So you can actually pick the galaxies that you're interested in, that have the properties you're actually interested in. I want to give an example about it, which actually NGC1 features in, which is a paper that came out a couple of years ago. It's called Larger Lambda R in the Disk of Isolated Active Spiral Galaxies Than in Their Non-Active Twins. What these guys did is they were interested in so some galaxies are active, which means they have a black hole in the middle which is doing stuff. It's making it very bright, it's throwing out jets of material, whatever. The black hole in the middle is doing something dramatic. And what they were interested in doing is saying, is there some property of the galaxy that makes some things have these bright nuclei, these active galactic nuclei, and others not? If you're going to try and do that, what you want to do is you want to find a sample of active galactic nuclei, so galaxies that have these active galactic nuclei. And then you want to find another bunch of galaxies that look as much like them as you possibly can, just they're twins. And then you say, okay, so I've picked this galaxy to be as much like this galaxy as I can, but are there still any kind of systematic differences between the two, which might explain why one of them has an active black hole in it and the other doesn't? And so that's exactly what they did. So here is a couple of their galaxies. So NGC 2906 is a galaxy with an active nucleus. It's not a particularly bright one. It doesn't look very dramatic in this picture, but it does have an active black hole in the middle of it. And so they then went through, they found maybe a dozen of these galaxies, and then they looked for their twins. And it turns out NGC1 is a twin. And you can see it looks pretty similar. There's really not a huge amount of difference. So they look pretty similar. They've been selected to be same type of galaxy. They're both spiral galaxies. They were selected to be that. They were actually selected to have the same mass as each other, so they weigh the same amount, same mass of galaxies. They have the same absolute magnitude, so they're the same brightness as each other, and they're more or less the same inclination. They're not, one of them's not very face on and the other very edge on. So they've been selected to be as identical as you can. And the only reason you can select pairs of galaxies like that is because you've got, thousands and thousands of them to start with. So you really can trawl through and find the ones that are the twins for the ones that you're actually looking for.
So if I have a copy of the NGC catalogue open on my computer, there's quite a few different sort of criteria, vital statistics for each one.
Not in actually not in the original catalogue. If we look at, so here's the original catalogue. Let me find a page from the original catalogue. So there isn't actually a whole lot of information, right? That's NGC1. It says what its catalogue was in the general catalogue. It turns out it was one in that catalogue as well. And then there's a bit of information about what other people have observed it. There's a bit about where it is on the sky. So that's its coordinates. It's a bit about how those coordinates might change just due to the precession and so on. And then there's a little bit about what it looks like. And so I can't remember what these stands for. I think F galaxy, which means it's faint. It's an S galaxy, which means it is small. And it's an R galaxy, which means it's round. So that was the only information. It says it's faint, small and round, and it's between star 11 and star 14. So that's telling you where to find it on some star chart or other. So this was the only information there was in the original catalogue. But of course, since then, people have gone back and observed them and learned a lot more about them. So there are kind of expanded versions of this catalogue that give us all that extra information about what the mass of the galaxy is and what type it is and what inclination it's at and all those other things that will match to find these twins. So this just sort of provided the starting point for the catalogue, but there are kind of catalogues that have more information in them.
So this paper that you have pointed out that has NGC1 and its twin, does it actually shed any light on the actual question as to why one's got an active, why one's active and one's not?
It does, in a rather surprising way. So this lambda thing they talk about, that's basically about how much the galaxy, so the stars are all moving within the galaxy and they can be moving in a nice orderly fashion, so they're just orbiting all around in circles, or they could all be moving in random directions, okay? Lambda gets bigger as things are more rotationally supported, so more kind of orderly motion around. And what they found was there's this systematic difference between these galaxies which were chosen to be identical to each other in terms of the way they look, but there was a difference in the way that the stars are moving around, and in the sense that the ones that were active galaxies tended to have more orderly motion, and the ones that were not active galaxies tend to have slightly more random motion in them. And so I can even...
It's not what I would have expected.
No, nor me. Nor them, I think, reading their paper. So here's the plot which actually shows it. So here's this whole bunch of galaxies. And so our galaxy was NGC 2906, which is this guy here. And then the best twin, which is NGC 1, is up here. So this is the difference between the degree of rotational support for the one that's an active galaxy versus its twin. And so if there was no difference in rotation, then they'd just be all randomly distributed about 0. But you can see they're really systematically shifted upwards. And that means that the rotational support for the AGN ones is bigger than the rotational support for their twins. It's a slightly controversial result because the prevailing view about active nuclei is whether you see a galaxy with an active nucleus or not is pretty much random, right? That actually it's thought that things just switch on from time to time and then switch off again. And so the prevailing view is just whether on, the number of things that you see as active galactic nuclei is just to do with this duty cycle of what fraction of the time a galaxy is in this active state versus not. And of course, if it's just random that you're just seeing the same galaxies and some of them you catch in this active state and some of them you don't, then there shouldn't be any differences between the galaxies. They shouldn't be rotating differently because that's kind of a long-term property of the galaxy. And so whether or not something's switched on or switched off shouldn't change the overall properties of the galaxy. And so this is a slightly unexpected result, that it looks like there is a systematic difference between the galaxies that tend to have these active nuclei in them and the ones that don't. And I still think we don't understand exactly, clearly this is a relatively small sample, it's what, 1, 2, 3, 4, 5, 6, about eight galaxies. Maybe a larger sample, maybe they just got unlucky with the statistics. It's kind of unlikely because it's pretty systematic, right? It's not like, a few of them are above and there's a few more above than below. They're almost all above the line here. And so it does look like a pretty robust result, but it does mean we have to think a little bit more about, well, why is it some galaxies are active and some aren't? And it can't just be this random thing of something switch on and switch off again.
Do you know what I think about? If we ever meet a civilization that lives in NGC1, how they'd feel about the fact that we're in number 1 on our catalogue.
We're number 1.
And I wonder what number the Milky Way is in the catalogue of other civilizations.
And it's going to be, just kind of down to chance, right? Because it's to do with how our solar system is oriented and what direction and how the Earth rotates and all those things. That is completely arbitrary. One galaxy really is very much like another galaxy. So why you pick one to be number 1 and the other to be 7,217 is, it really does come down just to chance.
I know why this is invalid, but I feel like they should have made Milky Way NGC1 just like as an honorary position.
Yeah, but that will get really confusing, right? Because there are NGC objects within the Milky Way because it's got star clusters in as well as galaxies. So there are bits of the Milky Way that have NGC numbers.
When you have an object that takes up a lot of the sky, say Andromeda, where do you put its right and left ascension is like the center of the object? How do you...
Yeah, so you just pick the middle, basically. All of these, the coordinates are kind of defined to be the center of the galaxy.
What if it's an irregular object that has no obvious center? Most
irregular objects are small enough it doesn't matter very much. I guess the ones it would matter for are things like the LMC and the SMC. But again, you run into this problem because they're actually resolved into individual bits. There are actually star clusters within the Magellanic Clouds that have their own NGC numbers. So yeah, so when you're trying to give a whole galaxy an NGC number, it probably doesn't matter that much because it's relatively small on the sky.
1 and type 2. So, you know, with the supernova, we end up with type 1a and type 1b, type 1c. I've even heard people talk about active galactic nuclei as well as like, oh, this is a type 1.8.